graphing today, but that doesn't mean we're done graphing. We got lots of graphing to do yet. Today we're going to learn, though, how to find intercepts. So when you were graphing in the assignment for yesterday, you should have discovered that that line crossed the x-axis and the y-axis at some location. You just didn't necessarily always figure out where that was, because we used a table and we may not have had those points in our table. But what I'm talking about is, can I give your attention over here? X-intercept means the point where the line will cross the x-axis. Well, here's the x-axis right here. Here it is. So I can put a point on that anywhere I want. It does not matter where I put a point on that. Wherever there's a point, that point would be called the x-intercept of the graph. Well, can anyone tell me what do all those points have in common, though, that we could say every single one of those points and any other point that somebody comes up here and puts on the x-axis, what do they all have in common? Brighton?
X is 0.
X is 0? So here's the origin. I'm going to go over to this point right here. 1, 2, 3, 4, 5, 6. What's the name of this ordered pair? 6, 0. Okay, Brighton, you're the closest to this one. What do you think this one's name is, Brighton? It's just an estimate, if nothing else. Okay. Probably a half. And 0. Okay. How about this point right here? 1, 2, 3. What would the ordered pair name be for this point? 3, 0. Okay. Well, how about this point? And here's the origin. 1, 2, 3 going to the left. Negative 3, 0. Are you starting to see a pattern going on here, Cameron?
All the x's have 0 as a line.
Yeah, all the x-intercepts, all those points on the x-axis have a 0 for their y value. So not for the x value, and that's probably what you meant to say, didn't you, Brighton? Yeah. So the x-intercept is the x-coordinate of the point where the graph crosses the x-axis. The y value of this point, we just said, is always 0. So the y value is always 0. That's an important thing to keep in mind, because when we're trying to find the x-intercept without a graph, we're really looking for those x values, like negative 3, 1/2, 3, 6. We're really looking for those x values. Those are considered to be the x-intercepts. Well, the y-intercept, where do you suppose the y-intercept points lie?
Y-axis.
On the y-axis. So any point on the y-axis, wherever the line crosses the y-axis, those are called the y-intercept. Well, anybody think they know what all those points have in common? What are all the points that I would go ahead and put on the y-axis over here? If I stuck some points on here, no. What would all those points have in common? Isaac?
1. 1.
Oof. Josh? The x value is always 0. Because look at here. 1, 2, 3, 4 down. I didn't go left or right, so its ordered pair name is 0, negative 4. This one, I go up 1, 2, 3, 4. What's this one's name then?
0, 4.
0, 4. I go up one more. What's that one's name? 0, 5. So all of those points have the same x value. So the y-intercept is going to be the y-coordinate of the point. So like over there, we have negative 4, 4, 5. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. The x value of this point is always 0. Okay, we need our books open to page 237. And we're going to do, it says, the check it out, 1A. So the check it out is at the bottom of the page. It says find the x and the y intercepts. Okay, let's again remember, x-intercept means the x value of the point where y is equal to 0. Or in other words, the x value of the point that sits on the x-axis. The y-intercept means the y value of the point where x is equal to 0, or in other words, the y-intercept is the point on the y-axis. So anybody want to offer up what they think in 1a, the graph for 1a, what do you think is the x-intercept for that one? You just give me the x value, that's all we gotta give. Okay? Everybody fill something in your notes. Everybody fill something in your notes right here. Give an x-intercept, and then we'll all compare answers, see if we all have the same. Okay? Well, while you're at it, why don't you do the y-intercept too? What do you think the y-intercept is for that graph? So they give us the graph, it's really easy. What do you think the x-intercept is for that graph? Brighton?
4 and 0.
No. Cameron? X-intercept, that's what I'm asking for. The x-intercept for 1a.
-2.
-2. Anybody agree with Cameron that it's -2? Yeah, it's crossing the x-axis at -2. That's all you gotta look for. Where's it crossing the x-axis at? The y-intercept, we're gonna look for where's it crossing the y-axis. So, JC, what is the y-intercept? -3. +3. Which one do you want? +3. JC says the y-intercept is +3. Do we agree? Is it crossing the y-axis at 3? Yeah. Okay. So when we're looking for the x and y-intercept, x-intercept, we're looking for the x. What's the x value where it crosses the x-axis? When we're looking for the y-intercept, we're looking for where is it crossing the y-axis at? What's the y value where it's crossing that axis? So from a graph, it's actually going to be a lot easier. There's no work to show. Okay? So notice we didn't show any work, we just had to look at the picture. Anybody got questions about that? Because now we're going to the ones where we do have to work a little harder. Okay. Because we're going to do we're going to do 1b on this one also. To find the intercepts from the equation, in other words, look at 1b in your book. Is there a graph there for that one? No graph. So if there's not a graph, do you want to go through the work of making a table and graphing it? No, that was a lot of work yesterday, wasn't it? So instead of making a graph, what we'll do is to find the x-intercept, we're going to put 0 in for what?
Right.
No. All the points on the x-axis have a y value of 0. So we're going to put 0 in for y. So think of it like this. If you're solving for the x, 0 is going in for the other one, the y. And solve that then for the x. Get that equation solved for x then. And you'll have your x-intercept. Y-intercept. Now what we're going to do is we're going to substitute 0 in for, we're looking for y, so we're going to put 0 in for x and solve it for y. Okay, so here's our equation, -3x plus 5y equals 30. Let's start with the x-intercept. X. Got to put 0 in for no, the other. Y. So -3x plus 5 times 0 equals 30. We're putting 0 in for y. Okay, what is 5 times 0? 0. What is -3x plus 0? -3x. Now what do we do? Divide by -3. Divide both sides by -3. And we'll have our x-intercept. What is it? X equals? -10. There's our x-intercept. If we graphed this equation, it would cross the x-axis at negative 10. Questions? Okay, to find the y-intercept, put 0 in for,
Y.
no, the other, for x. So we're going to say negative 3 times 0 plus 5y equals 30. So we're using this equation right here, you guys, and we're just substituting into it. So we're using our equation, we're substituting in. We're looking for y, so 0 goes in for the other. So what is negative 3 times 0? 0. What is 0 plus 5y?
5Y.
5y. Finish solving that, you know. And get the y-intercept. So what's our y-intercept?
6.
6. So that tells us what again?
The line will cross at 6 on the y-axis.
Yeah, the line will cross at 6 on the y-axis. So, let me just give you a little bit of a picture of this, okay? If we would have made a table, if we would have got that equation put so that we had a function rule and we would have picked some x values and made a table for it and graphed it, we just said, or Cameron just said, it would cross the x-axis at negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's where it's going to cross the x-axis. It will cross the y-axis at positive 6. 1, 2, 3, 4, 5, 6. And how many points does it really take to draw a line?
2.
Just 2. I couldn't if I had a straight edge here right now. I'm going to have to rough draft it because I don't have a straight edge right now. Here's our line. That's how it would turn out on the graph. Okay? So there's a picture of what we just found. So those could have been 2 of our ordered pairs in our table, actually. It turned out to be. Okay. Anybody got a question before we practice some more on that? No graphing today. You don't have to graph. I just was showing you what, when you find them though, you should be able to visualize. You can say, oh, that tells me, I have a picture of this. Okay. This is on page 240. We're actually doing a problem that's in the homework set that you're not going to do. But tell me something that's different about this one that from the last one that we did. Can you pick out any differences with it? So if I remember right, it looked like this, the one that we just did on the front. Negative 3x plus, I already forgot, sorry.
Plus 5Y.
5y equals 30.
Yep.
Okay. What's different about this one versus that one? Just, something maybe you didn't notice. Trey?
The Y and the X is which one?
Yeah, well, they're not together on the same side, are they? Yeah. In that one, they're together on the same side. On this one, they're not. Okay, we're gonna do this one that we could actually move it so that they are, or we can work with it the way it is. Okay. So I'm gonna practice with you leaving it just like it is. I want you to be able to do it no matter what form it's in. I want you to be able to find the x and y intercept. So we're just gonna go right to work finding the x intercept. And remember, what do we do when we're looking for the x intercept?
Substitute 0.
Put 0 in for y. If you're looking for x, put 0 in for the other. So we're going to put 0 in for y. So negative 2 times 0. And this is why we don't shortcut it, because if you were trying to shortcut the last one, you might get in trouble with this one. So what is negative 2 times 0?
0.
0. 0 times anything is 0. And these guys are not like terms over here, so I can't put them together, can I?
Nope.
Even though I think you might want to try, right? But you can't? Okay. And then, I got to solve this for x, don't I? So what are we going to do next? Grows? Add 6 to both sides. We got to get those x's alone. So we say, okay, Let's get that 6 out of there. 6 is being subtracted, so we will undo it by adding it. And now we have 6 over here and 3x on the other side. Trey?
Why are you finding the y?
We're not, we're looking for x. We're looking for the x-intercept.
Yeah, but you do the y.
I put 0 in for y. And it's no longer there.
But we're finding the x-intercept.
I know.
Yeah, you just substitute 0 there.
No, like,
I think you're confused because now the y was on this side and now we have a 6 over there and you think we're kind of finding the y, but we're not. What are we gonna do next? Rose? Divide by 3. Okay, divide both sides by 3. And what do we get? 2. So our x-intercept is 2. So if you end up with x equals a number, you found the x-intercept, didn't you? So what does that tell us again? Turn to your partner, table partner, and tell him, what does that tell you?
that's where the line is.
Turn to your table partner and tell him. Dakota, you tell Mrs. Agerman, Brian, you're going to tell me. What does that should tell us? That's right, good job. Okay. Okay. So hopefully you all decided that this is where the line's going to cross the x-axis at this value, isn't it? Okay, y-intercept. Go ahead, find the y-intercept now.
So we're going to put it in for x.
And now we're going to put 0 in for x because we're looking for y.
But if you're looking for y, we put it in for.
Yeah, but you always put the 0 in for the other one.
That's been this one. That's been this one.
I've got the substitution step up there if you want to just double check yourself and see if you have it started right. Dakota?
So
You can stand
we're always using 0.
We're always using 0 for either x or y. We're always using 0 for the one we are not solving for. And I'm going to change that subtraction to add the opposite. What's our y-intercept? 3. It is 3. Should have found the y-intercept to be 3. Or in other words, just tell us again. If we visualize this, it would be,
This is where the y-axis
this is where it's
crosses
crosses the
y.
y-axis. This is where it crosses the y-axis. Okay. Okay, anybody get stuck somewhere on there and it didn't work out for you and you want to talk about it? Isaac?
I got 0.
You got 0, huh? Well, can you follow the word that's up here and see where you might have gone wrong? Because that's not enough information for me. You got 0. Sorry. Okay, well, let's move on to the next one. And notice something about this one. Wow. This is a crazy equation. Stand up, Dakota. So we got y's on both sides. We've got x's on both sides. What do you suppose we could do? Right?
Put like terms together.
Put like terms together. Get it so we don't have x's and y's on both sides. Well, if we have to put them together and they're not together on the same side, what do we have to do? We have to say, oh, okay, well, first of all, first thing I'm going to do is I'm going to change this to that subtraction to add the opposite. So all I'm going to do is get that subtraction changed to add the opposite. And now I'm going to say, well, 4y plus 5x on that one side, they're not like terms. You know, 2y plus negative 3x plus 16, none of those are like terms. So now I just got to start moving things, don't I? So let's get the y's and the x's together on the left side. Would that work? So if we're going to move the x's let's move the y's first. What would we do to move the y's?
Minus
Trey?
2. Do we add or do we subtract?
I don't know, what do we do?
We subtract 2y, 2 minus.
Because we can read addition backwards, so 2y is being added, so we would subtract, wouldn't we? Once on each side. As long as you do the same thing on both sides, if you're adding and subtracting, you only got to do it once on each side. And so now we have 4y take away 2y. What is that? 2y. Then we bring down our plus 5x. And then these guys canceled out. And now we have a negative 3x plus 16.
So we have,
Now we'll add 3x to both sides because a negative 3x is being added. So we add the opposite of that, which is 3x. So we add 3x to both sides, and we might as well line them up in the places where they can actually be added. And now we have that 2y comes down plus what?
8x.
8x. 5x plus 3x is 8x. These guys cancel, and we just have a 16. So now our equation is actually a little more user-friendly. So now we're going to say, okay, it's ready to find the x-intercept. Let's find that one first. And you need to, let's identify them. What do we do when we're finding the x-intercept? Rose?
You substitute 0 in for
You put 0 in for y. Yeah, so 2 times 0 plus 8x equals 16. Well, 2 times 0? 0. Zero plus 8x? 8x. And our last step?
Right.
By
8.
8. So what is our x-intercept, class?
2.
It is 2. Okay, you go find the y-intercept now. Okay? Write it down that you're finding the y-intercept next. The y-intercept for this equation. We know what the y-intercept is. 8. You should have gotten 8. Now, let me give you a little heads up. They don't have to be integers. They can be fractions. So, if you're working it and you're like, oh no, 3 doesn't go into 2, what am I going to do? You're going to leave it as 2/3. You're going to say the x-intercept is 2/3, or maybe the y-intercept is 2/3, whichever one it was. We can have fraction intercepts, okay? Okay, anybody got questions? Anything that still needs to clear up for you?